Chapter 3, Aftertreatment. Diesel emissions requirements are more stringent. These requirements have contributed to suppliers adding exhaust aftertreatment systems in order to manage the emissions released into the atmosphere. It's necessary to treat diesel exhaust similar to the treatment of exhaust in the middle to late 70s. This illustration outlines the progress of emissions requirements for diesel over the years. Note that by 2010, the allowed emissions of NOx and particulate matter, also known as smoke or soot, was a tiny fraction of the allowed emissions in the mid-90s. Starting back in the early 2000s, a requirement for some diesel engines was to use an after-treatment device called a diesel oxidation catalyst, or DOC. Initially, these were used to control carbon monoxide, hydrocarbons, unburned fuel, and partial control of exhaust smoke. Although not shown on the chart, carbon monoxide and hydrocarbon regulations are an issue when the diesel engine is cold. Identified as white smoke, these pollutants come out of the exhaust pipe on freezing days or just after startup. However, black smoke, witnessed coming out of the exhaust pipes of trucks on a more continuous basis, means there is a bigger problem to address. Black smoke comprises small particles of two kinds: small liquid droplets of unburned fuel and solid particles called soot. The DOC can take care of these liquid droplets by using a catalyst, usually platinum-based, by oxidizing them through a chemical reaction into carbon dioxide and water. You can control carbon monoxide in the same manner. What is a catalyst? It is a can in the exhaust pipe that contains a substrate, usually made of a ceramic material, that has a coating to facilitate chemical reactions. The exhaust gas passes through the channels in the substrate, coming in contact with the coating. The catalyst coating is very effective in facilitating this chemical reaction at normal engine exhaust temperatures. Without the catalyst in place, these reactions would not occur, and the CO and hydrocarbons would enter the atmosphere. In 2007, the job of the DOC in the exhaust system became even more important. 2007 is when the diesel engine manufacturers had to add diesel particulate filters, or DPFs, to the exhaust system to further control exhaust smoke. The DPF filtered out the rest of the diesel smoke, or soot, that is the solid particles, and captured them in a filter. As the filters filled up, cleaning and replacing them became another task. There are two ways to clean out the DPF with chemicals rather than removing the filter and replacing it with a new one. One of those ways involves the DOC. The DOC is not only effective at oxidizing carbon-based compounds like hydrocarbons and carbon monoxide, but it is also effective at oxidizing nitric oxide, also known as NO. NO is a product of diesel combustion and is also a regulated pollutant by the EPA. If you can use the DOC to convert the nitric oxide to nitrogen dioxide, NO2, then the particulate filter can then use that NO2 to combine with carbon soot particles to make NO and CO2. This chemical reaction is not the complete answer to cleaning out the particulate filter, but it helps extend the intervals when an alternate cleaning method called regeneration needs to be used. The bad news is that both NO and NO2 are regulated pollutants by the EPA. This chemical reaction doesn't reduce the NO that will eventually enter the atmosphere. Therefore, you still need to manage the NO output of the exhaust gas. Another use of the DOC is to raise the temperature of the exhaust gas so that the carbon in the filter will oxidize into CO2 and water. This is done by dosing additional diesel fuel downstream of the turbo, which we will discuss in detail in a later video. In summary, the DOC is an integral part of today's complex diesel after-treatment systems. Please check out our other training segments. They will discuss the functions of both the DPF and the most recent addition, the Selective Catalytic Reduction, or SCR.